Let us now look at a very important sound feature called Mobility Robustness Optimization or MRO. For you to understand this feature, you should be familiar with handover procedures. We have an old tutorial on that topic. It's one of the first ones we did, so it's not very polished. You can see the link on top right corner. MRO was introduced as part of 3GPP Release 9. MRO helps eNode B to find the problems in handovers, and then by using this information, it can adjust the thresholds to ensure that these problems disappear. There are three main causes of failures as can be seen in the pictures here. Let us look at them one by one. The first is intra-RAT late handover triggering. Intra-RAT means within the same technology. In our case, this means from 4G to 4G handover. In intra-RAT, there can be two cases, intra-frequency and inter-frequency. These scenarios are applicable to both these cases. Right. So what does late handover triggering mean? It means that the old base station should have started the handover procedure before, but it was late in starting it. In the meantime, the device lost coverage from the original cell even though it is in coverage area of the new cell. Because the handover procedure was not complete, the UE sends a radio link failure or RLF message. Don't worry if you don't understand this completely, we will soon look at the signaling. In case of early handover triggering, the eNode B hand over the UE to the new cell, but the UE comes back to the old one before the procedure could be complete. You can see the coverage scenario where this can happen in the diagram. The last scenario is handover to the wrong cell. Here there are two different sub-scenarios. One in which radio link failure happens after the handover and the other in which RLF happens before. Okay, so let us start looking at each of this scenario one by one in detail. Let us start by late handover triggering. Here the old eNode B started the handover procedure with the UE, but it was already too late. There is no message back from the UE and the old eNode B realizes that there is a radio link failure with the UE. In the meantime, the UE has already started a contention based random access procedure with the new eNode B. Once the random access procedure is successful, the UE will send the RRC connection re-establishment request message with old cell ID and CRNTI. The eNode B would then send the RRC re-establishment message with all the necessary information about the channel establishment, etc. In the RRC re-establishment complete message, the UE can inform the eNode B that the UE has additional information about the radio link failure. The network may not always be interested in this information for a variety of reasons. One of them could be that the new optimization procedure has started and would take some time to complete. In the meantime, there is no point looking at the old logs or information. Now, in case the network was interested, it can send the UE information request message asking for the RLF report. The UE would send back the UE information response message with the last set of measurements and any other information. The new eNode B can now inform the old eNode B about the RLF problem using the new release 9 message known as an X2 application part radio link failure indication. The old eNode B can take action based on several RLF indication messages and adjust its threshold to reduce such failures. The procedure to update the thresholds is vendor implementation dependent. In this case, the old E node B started the handover procedure too early. As a part of handover procedure, the UE gets the new cell ID and CRNTI. Before the handover procedure could be complete, the new E node B realizes that there is radio link failure with the new UE. The UE in the meantime realizes that it can still see the old cell and does an RRC re-establishment procedure with the old E node B. So this part is the same as before in the case of late triggering. However, in this case, when the old E node B sends the X2AP RLF indication message, the new E node B sends another new release 9 message X2AP handover report, indicating that the old E node B started the handover procedure too early. The old E node B can now use this information to adjust its measurement thresholds accordingly. The final scenario is the handover to an incorrect cell. In this case, the old E node B asked the UE to hand over to new E node B. That procedure failed and the UE ended up on third E node B. This third E node B then informs the new E node B about RLF indication, which in turn sends handover report to the old E node B indicating that it performed handover to the wrong cell. This scenario is applicable to intra-RAT as well as inter-RAT procedures. Inter-RAT means from 4G to 3G or 2G. MRO was enhanced in Release 10 to detect unnecessary inter-RAT handovers. After handover to the other RAT, the new access network can configure LT measurements for the nearby cells. If the power received is sufficiently high, the network can tell the old LTE node B that the handover was triggered unnecessarily. This is informed to the old E node B using the S1AP direct transfer procedure. Here are some references in case you want to read further on this topic. The first reference is a paper available online that actually provides insights, including algorithms, etc., that has a lot of valuable information. So hopefully we were able to explain MRO or Mobility Robustness Optimization in a simple way. In the next part, we will look at Random Access Channel or RACH optimization. In the meantime, thank you for watching and goodbye.